With cookies. A little bit of background on the reaction. It is a chemical reaction that occurs between amino acids and reducing sugars, and this is going to give off the browning color we see on many different types of foods, as well as certain odors and flavorings such as like a nutty or savory type flavor. The reaction is non-enzymatic, and it was found by Louis Camille Maillard, who is a French chemist, and he discovered this in 1912 during his attempt to create a biological protein synthesis. So many of the different foods that we eat every day or choose to eat are going to be steak, chicken, bacon, bread, cookies, biscuits, and all of these will take part in the Maillard reaction. So the reaction starts with an amine reacting with a reducing sugar to synthesize a glycosylamine, and next an Amadori rearrangement will occur to produce an amino-deoxyfructose derivative, and then a derivative of furan is then synthesized and it will react with other components to polymerize the dark brown color we see in the food. This will allow, as I stated, the browning of the food at lower temperatures than actually needed for this caramelization to occur. This involves sugars and eggs for the reaction, as well as flour to obtain the nutty and savory taste within the food. And then here is just a mechanism of one of the possible reactions. So we can see the amine attacking the reducing sugar, and water is a byproduct of this, though due to the high temperatures that we often cook foods at, that'll be removed quite quickly from the environment. And then the next part of the experiment obviously will be the cooking procedure, in which we will have the core ingredients of flour, the different types of sugars, baking soda as well, and the eggs for the protein. And our instructions will just be as follows in the video. First, we're going to be taking the white and brown sugar along with butter to make a cream form, and then we're going to be adding the rest. And now for the next step, after the sugar and butter mixed, we're going to add in our eggs and vanilla extract, along with dissolved baking soda and sea salt. Now, in our last and final step of making the cookie dough, we're going to add in the flour along with the chocolate chips. And now we're just going to mix it all together. Okay, now we're going to attempt to take all of this out, but it's slightly stuck. Now I'll be using a scooper to just scoop them into balls and put them on the tray. So I just wanted to also say some few facts that I found that were pretty interesting about the Maillard reaction. For one, not all of the components of the reaction are still entirely known yet because it is so complex. Things such as certain flavors you obtain from the Maillard reaction are still unknown to chemists. The reaction also occurs at many different types of temperatures, though baking cookies at 350 degrees will happen much faster than if you let something cook over a very long amount of time. And aside from the temperature, time and pH also will affect the Maillard reaction, which is also a reason why baking soda is added into the recipe, because this will aid in the strengthening of the smells and flavors of the cookies. Other chemistry within baking cookies. So the water is produced not only from the Maillard reaction, but there's water in the dough that we created. And what this does is this will turn into vapor and it'll make space within the dough to make it fluffier. And this is what gives cookies like that little soft texture as well. And then baking soda breaks down and produces carbon dioxide as well to also raise the cookies, because that carbon dioxide is pushing out. And then butter aids in the spreading of the cookie by loosening the structure. So then this allows for our cookies, once we ball it up in the little dough balls, to spread out and be the sizes that we desire. And then aside from the Maillard reaction, caramelization does occur to break down sugar for further taste.